Hi everyone, I hope you're doing well. Today we're going to talk about derivatives of trig functions. And these first 6 trig functions, fortunately or unfortunately, you really should have these memorized. What we're going to do is we're going to show that if you just know the derivative of sine and cosine, you would be able to derive or figure out the rest of them. And if you want to justify to yourself why the derivatives of sine or cos are what they are, you can do it by definition. So you can look at the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, but it's not necessary for us to prove that. So we'll state them, but we will then go through and prove why tan, cotan, secant, and cosecant are the answers that they are. And then we'll do some additional problems with chain rule to get some more practice. Okay, so derivatives. So what is the derivative of sine? The derivative of sine is cosine. And then the derivative of cosine, be careful, a lot of people forget the negative, is negative sine x. All right, and now these other ones for now, we'll list them and then we'll show why they are what they are. So the derivative of tan is going to be secant squared x. And remember, when I say secant squared x, it means secant x, and then all of that is squared. Okay, so just make sure that you're okay with that notation. And then for cotangent, we have cosecant squared of x, and this one also has a negative. The derivative of secant, this one is secant tan. And then the cosecant, this one is going to also have a negative. Cosecant x, cotangent x. Okay, the ones that I'm personally, that you see a little bit more often is obviously sine and cosine, tan and secant. Those are the ones that are most commonly used. I personally always have to remind myself of these two, and if I forget them, I just derive them, as you're about to see. So let's first start off and prove the derivative of tan. And to prove this, what we're going to do is use the fact that tan can be expressed as sine over cosine, and then we can just use the quotient rule. So it's extra good practice with all the derivative rules we learned last week. So for quotient rule, remember, we go the derivative of the top, so d dx of sine x, times the bottom, minus the derivative of the bottom, so d dx of cos, times the top. And then all of this, we divide it by the bottom squared. So cos x all squared, or cos squared x, whatever you prefer. All right, so now what do we have? So the derivative of sine, remember that was cosine. So we have cos x, and then this is times cos x, minus the derivative of cos. Now I'm going to put brackets here to make sure that I don't make a mistake with my negatives. So negative sine x times sine x. And again, all of this is divided by, and now I'll write cos squared x. So the first term here, we're going to get a cos squared. The negatives will cancel, and we'll get plus sine squared. So cos squared x plus sine squared x, all divided by cos squared x. Now the top, we know what this is. Sine squared plus cos squared, this is just equal to 1. So what are we left with? We're left with 1 divided by cos squared x. And this is precisely what secant squared x is equal to. Secant is 1 over cosine. And that's how we get our derivative here. Okay, next. Now let's look at the derivative for secant. And now we can use the rule where secant is really just 1 over cosine. And we can do the quotient rule, or if you wanted to, you could write this as cos to the power of negative 1, and then you could do the chain rule. Okay, so it's up to you. I'm going to do the quotient rule just because I personally prefer it when especially I have a coefficient up top here, because when we take the derivative of the top, d dx of 1, well, that's just going to be 0. So it's going to simplify things quickly. So the quotient rule, the derivative of the top times the bottom minus the derivative of the bottom times the top. And again, this is all divided by the bottom squared. So cos x, and then we're going to take 2 of those. So now this first part here, this is all just 0. So what are we left with? We're left with minus, remember, the derivative of cosine is minus sine. So just to make sure I don't mess up my negatives, I'm going to go minus bracket minus sine x. And then that's just times 1. All right, and then we have divided by cos squared x. Now, when you get to this point, you may be a little bit like, I'm not sure what to do. Remember that secant is 1 over cos and tan is sine over cosine. So what we're going to do, the sine on top becomes positive, but I'm going to split up my bottom into cos times cos and write this as 1 over cos x. And then this is times sine x over cos x. And now this means that we have secant, and then we have tan. Okay, good. Now this one is very similar, except we're dealing with 1 over sine, and we want to find the derivative of cosecant. So same thing as before. Let me zoom in a little bit. We're going to have d dx of the top. Okay, so this whole first term is going to go to 0. Minus the derivative of the bottom, d dx of sine x, and then times the top, which is just times 1. And again, this is all divided by the bottom, which is just sine, and then we square it. So this first term, this is all gone. The derivative of sine is cosine, so I have the minus, and then times cosine, and then times 1. And then this is divided by my sine squared x. And again, what I'm going to do is I'm going to write this as minus, I'll go 1 over sine. Okay, so this will be for my cosecant. And then I have cosine over sine, which is 1 over tan, which is just cotangent. Okay, so we have minus cosecant x, cotangent x. All right, now for cotangent. So cotangent, we can write this as cos over sine. And then we are just going to do the quotient rule again. So we'll do the derivative of the top. So d dx of cos times the bottom, which is sine, minus the derivative of the bottom, so the derivative of sine, times the top. And then again, this is all divided by, we had what? A sine on the bottom. So we're going to have sine x, and then we're going to square that. All right, so now, d dx of cos, this is negative sine, so I'm going to put brackets to make sure I don't mess up my negative. And then that'll be times sine x. And then I have minus, the derivative of sine is cosine. So we have cos x times cos x. And then this is all divided by sine squared x. So I'm going to end up getting a sine squared here and a cos squared here, but I have negatives in front of both of them. So in order to use the identity sine squared plus cos squared is equal to 1, I'm just going to factor out my negative. And I'll do big brackets, sine squared x plus cos squared x. Okay, because I had a negative in each term, so I can factor it out, divided by sine squared x. And by our identity, this is 1. So what am I left with? I'm left with negative 1 divided by sine squared x. 1 over sine is our cosecant, so we have negative cosecant squared x. Okay. So remembering sine and cosine are the most important. Technically, you can always derive the rest of them if you forget them, okay? But you need to know sine and cosine. So those are if we just have the trig functions on their own, but now we're going to do a few examples where we have not just an x inside of the trig function, but we have something else. Okay, so let's start off with this one. So let's say tan bracket 9x squared bracket. So we know that the derivative of tan, that's going to be secant squared. So secant squared of the inside. But because that's not just an x, I can't times it by 1. I have to do the chain rule where I then take the derivative of the inside. And remember, for chain rule, start from the outside, work your way in. The outside part is tan, the inside part is the 9x squared. So I'm left with secant squared, 9x squared, and then this is times 18x. Okay, and then you don't have to do this, but I personally prefer to always put coefficients and x's on their own out front. So I'm going to write it as 18x, secant squared, 9x squared. Okay, for the next one. Now again, remember, this secretly means we have to be really careful here because we almost have double chain rule. This means sine of the inside, so 2x, and then all of this is squared. So thinking about taking the derivative of this, if you're not as familiar with this notation, may be a little bit easier. So we start from the outside, and the outside we have a squared of stuff. So we're going to do power rule, where we bring down the 2, leave the stuff inside here alone. Okay, so this is just to the power of 1, so we don't have to rewrite that. And then we have to do the derivative of the inside. So d dx of sine 2x. Okay, so let's rewrite what we have. So 2 sine of 2x. Now, sine, the derivative of sine is cosine. But again, in the inside of cosine, we don't just have an x, we have 2 times x. So we have to do d dx of the inside. You have to keep doing this chain rule until you're just left with x's, basically. Okay, so now what do we have? So now we have 2 sine 2x cos 2x, and the derivative of 2x, well, that's just equal to 2. So I'm going to bring this 2 up front with this one, multiply them together. 4 sine 2x cos 2x. All right. Now let's do one with a larger exponent. So now we're going to do our cotangent. And remember that the 6 here really means we have cotan x all to the power of 6. So we're going to start from the outside, work our way in. So the outside, we have a power of something. So we're going to do power rule. So bring down the 6, ignore the stuff inside. Okay, subtract 1 off the exponent. And then we're going to go d dx of whatever is inside. So cotan of x. Now the derivative of cotan of x, remember, that's negative cosecant squared. So I have 6. I'll now write the cotan x of 5 as cotangent 5 of x. You can leave it like this if you want, okay? But now this is multiplied by negative cosecant squared of x. And secretly, even though we don't just write it because it's x by itself, secretly we do have d dx of x. Okay, but it's just equal to 1. That's why we don't normally write it if we just have x on its own inside. So I'm going to bring this negative. Remember, this is multiplied. So I'm going to bring this negative up to the front. And then I have negative 6 cotan 5x cosecant squared x. All right. Now let's do another one. Okay, let's do one now that looks like this. So I have cosecant, but now on the inside, I have e to the 2x. Okay, so start from the outside. What's our outside? Our outside is this trig function. Okay, so remember, the derivative of cosecant is negative cosecant cotangent. Okay, so we have negative cosecant of whatever we have in the inside, cotangent of whatever we have on the inside. Okay, don't let that inside trip you up. And now I can take the derivative, the d dx, of the stuff in the inside. the e to the 2x. Okay, so let's rewrite the first part. These two trig functions. Now, the derivative of e to the 2x, remember, for e to the something, we rewrite what we have, and then we look at the derivative of the thing in the exponent. If it's just x, the derivative's 1, so we don't have to worry about it. But in our case, we have 2x. And d dx of 2x, well, that's just equal to 2. So I'll bring that 2 up to the front because all these terms are being multiplied together. And I'm also going to bring this e up to the front. Again, I prefer to bring those things up to the front. It's just easier for me to read. You don't have to. So we end up getting negative 2 e to the power of 2x, cosecant e to the 2x, and then cotangent e to the 2x. All right. Let's do one now where we have to do the product rule. Okay, so we can see what these trig functions look like for slightly simpler things. So remember, product rule is the derivative of the first times the second plus the derivative of the second times the first. So the derivative of the first, well, that's just 2x. So we get 2x secant x for the first term. And now the derivative of secant, that's secant tan. And I'll bring the x squared up to the front since all this stuff is being multiplied. So secant x tan x. Okay, and for our last one here, let's do sine with inside of pi e to the x. And I want to find my derivative at x is equal to 0. So to do this, first thing we find our f prime. Once we have our answer, then we plug in 0. Okay, so start from the outside. The outside is a sine. So the derivative of sine is cosine. But then we do the derivative of whatever is inside. So d dx of pi e to the x. And this cos pi e to the x. Our derivative in this case, we just have pi, that's a constant, and then the derivative of e to the x is just e to the x, because we have d dx of e to the x, which is equal to, rewrite what you have, take the derivative of the exponent, but that's just equal to 1, so we don't have to write it, we can just directly write e to the x. And now what I'm going to do is I'm going to plug in my value for x that I want. So I have cos pi e to the 0 times pi e to the 0. So e to the 0 is just 1. Okay, and I'm going to bring my pi up front. Actually, I'll do that in a second. So cosine of pi, and then I just have pi here. So cosine of pi, this is equal to negative 1. And then this is times pi. So our answer is negative pi. Okay, so hopefully you found that helpful, and take care.